Hey guys, so we're going to do an example problem for integration using linear partial fractions. So as you can see, we have this integral 2x minus 1 over x squared minus 5x plus 6, which may seem daunting at first to solve, but once we figure out how to use this new technique, it's going to become easy peasy. So first thing, the first step you want to use whenever you're doing integrals using partial fractions is factor the denominator. So we have to factor x squared minus 5x plus 6. So what factors of 6 add up to negative 5? So we have negative 3, negative 2, because negative 3 times negative 2 equals positive 6, and negative 3 plus negative 2 produces negative 5. So x squared minus 5x plus 6 is equal to x minus 3 times x minus 2. So this integral right here, 2x minus 1 over x squared minus 5x plus 6 dx is going to be equal to the integral of 2x minus 1 over x minus 3 times x minus 2. Cool beans. So the whole idea of partial fraction decomposition is you're essentially taking this really complicated rational function and you're breaking it apart into two easier to understand, two smaller rational functions. So here's where stuff gets weird. So we're gonna write out this equation: 2x minus 1 over x minus 3 times x minus 2 is equal to a over x minus 3 plus b over x minus 2. Notice, I essentially created two rational functions using the two factors from the denominator here, x minus 3 and x minus 2. A and B are just some constants. They're just some numbers. They're just some numbers that we have to solve for. So let's create an equation by finding common denominators. So let's rewrite this, everything on the left side. Now, if we want to add these two fractions together, we need to find a common denominator, which means that we have to multiply this fraction by x minus 2 over x minus 2. And multiply this fraction by x minus 3 over x minus 3. Good so far? So what we can do is multiply this entire equation by x minus 3 times x minus 2. Because whenever we do this, it cancels out all of these terms. So we're left with 2x minus 1 is equal to a times x minus 2 plus b times x minus 3. Cool. Now we have a simple equation that we can use to solve for a and b. So let's have x equal to 2, and we can use that equation to solve for b. Notice, the a term is going to cancel out because 2 minus 2 is 0, and 0 times anything is equal to 0. It's supposed to be a negative 1. So we find that b is equal to 3. Let me get another sheet of paper. So now let's solve for the a term. Here's the equation again. So now we want this b term to go to 0. So we can make it go to 0 by plugging in 3 for x. Because x minus 3, or not x minus 3, 3 minus 3 will be equal to 0, and 0 times anything is equal to 0. So we're left with 6 minus 1 is equal to a times 1, which means that a is equal to 5. So now we can go back to the equation that we wrote earlier, which was 2x minus 1 over x minus 3 times x minus 2 is equal to, now instead of a, we can put 5 over x minus 3. And instead of b, we can put 3 over x minus 2. Now we can go back to the integral that we wrote earlier, which was the integral of 2x minus 1 over x minus 3 times x minus 2 dx. Since we know that this expression is equal to this expression, we can substitute it into the integrand. So we're going to get 5 over x minus 3 plus 3 over x minus 2 dx. Now this is going to be much easier to solve than the original form that we had it in. First thing we can do is break this apart into two integrals. Now what we can do is take out the constants 5 and 3 outside of the integral. So now we can use u substitution to solve each integral individually. So for this first one, we can do let u equal to x minus 3. So if we take the derivative of that, we find that du will be equal to 1 times dx, which is right here. So if we do u substitution, we're going to find that this integral is equal to 5 times the natural log of u, which would just be equal to the natural log of x minus 3 once we plug in the value for u. So now let's do this second integral. So for this one, let's have u be equal to x minus 2. And if we take the derivative of that, we find that du will be equal to 1 dx. So let's do the substitution. We find that the integral is equal to 3 times the natural log of u, and in this case u is equal to x minus 2. So we write plus c at the very end because that gives us the solution to our original integral. So now, what were the steps that I used to find this answer? Anytime you're given an integral and you're expected to solve the integral using partial linear fractions, the first thing you want to do is factor to the denominator. Which is what we did first. Here we factored x squared minus 5x plus 6 into x minus 3 times x minus 2. The second thing you want to do is actually perform the partial fraction decomposition. Which was, if I can find the paper, which was what we did here. We broke up this large, complex rational function into two smaller rational functions. The third thing you want to do is solve for a and b, which was what we did here. So I wanted to solve for b, so what I did was plug in 2 for x, because I know if I plug in 2 for x, I'm going to get 0 here, and to cancel out the a term. Therefore, I can just solve for b. And I did the same thing here, where I plugged in 3 for x, so that the b term could go to 0 because 3 minus 3 is 0, and b times 0 would be 0. And then I can just solve for my a term. Once I have the values for both my a and my b, what I can do is rewrite the integral. So that's what I did here. I wrote the original integral and I rewrote it with the two easier to understand rational functions. And then you just solve the integral. So originally I just solved the integrals using u substitution, but there's a special formula you can use when using partial fraction decomposition for integration. And the equation is, if you're trying to integrate some function f of x over gx with respect to dx, and you can do the partial fraction decomposition into a over ax plus b dx plus b over cx plus d with respect to dx. If you're able to do this, that means that your integral will be equal to capital A over lowercase a times the natural log of the absolute value of ax plus b plus capital B over c times the natural log of cx plus d plus c, because it's an indefinite integral. And that's essentially what we did here. As in, here we can treat the 2x minus 1 as our f of x, and we can treat the x minus 3 times x minus 2 as our g of x. And we can treat our 5 as our a, so that's where that goes there. And we can pretend that there's a coefficient of 1 before the x, so it's like 5 divided by 1, so like capital A divided by lowercase a. And the ax plus b term would be x minus 3, and here the capital B term would be 3, and the lowercase c term would be 1, so that's like a 3 over 1, and the cx plus d term would be x minus 2. So that's how you do integration using linear partial fraction decomposition.